Today's lesson is on the law of sines. So my learning objective for today is I can use the law of sines to solve oblique triangles by applying proportional relationships with angle side angle, angle angle side, or angle side angle cases. All right, first let's just review what is an oblique triangle. An oblique triangle is a triangle have no right angles. So that includes both acute triangles and obtuse triangles. And as a reminder, each vertex of my triangle is represented by a point, which is a capital letter, and the sides across from the angles match the vertex, but in a lowercase letter. Okay, so we have 4 types of cases that we use to solve. So the first case is when I have one side and 2 angles. So they can be in the order of angle side angle or angle angle side. Or the second case where I have 2 sides and the non-included angle, and that's called side side angle. These are the cases that we are going to cover with the law of sines. And in the lesson with the law of cosines, we will cover the other 2 cases. So what is the law of sines? The law of sines shows that there's a proportional relationship between the angles and their opposite side. So it is the angle and the sine of the opposite side. So the standard form has the sides in the numerator and the sine of the angle in the denominator, and the reciprocal form has the sides in the denominator and the sine of the angle in the numerator. And you can use it in either order. Okay, so let's start out with. So the strategy for solving this is I want to draw a triangle. I want to label the 6 parts. There are 3 sides and 3 angles. Add the 3 given parts. And then when I am choosing, I need to set 2 of my 3 fractions together. I need to make sure I'm always choosing the fraction that has the side angle pair. I'm going to apply the triangle sum theorem, knowing that all 3 angles total 180. And the second fraction I'm going to use is the third piece of information with the given part. So I'm using all 3 pieces in the 2 fractions that I'm solving first. So the fractions need to be in the same order. I either have both sides in the numerator or both sides in the denominator. And usually we're solving these right now in degrees, so make sure you check your mode on your calculator and you're in degrees. All right, so let's do an example. Solve the triangle with the measure of angle A, and we're going to round 2 decimal places. Measure of angle A is 68.41 degrees. Measure of angle B is 54.21 degrees, and side A is 12.75 feet. You're going to round sides and angles 2 decimal places. So I would start by drawing a triangle, and the triangle can be any shape. It can be acute or obtuse. It doesn't matter. One of the strategies I personally use is I label my triangle in the same order so that when I'm putting the information on, I make less careless mistakes. So I usually use side A is the bottom left, side B is the bottom right, or angle B, and angle C is on the top. So we are given that the measure of angle A is 68.41 degrees. That side A is 12.75 feet. And that B is 54.23 degrees. So those are the 3 pieces of information I have. So the other thing I like to do is I have a graphic organizer. So I have angle A, side A, angle B, side B, angle C, side C. And that just kind of just organizes the information. So if you want to use this is how I do it. So angle A is 68 58.41 degrees, 12.75 inches, and 54.23 degrees. Okay, so when I'm using my fractions, it's very clear I'm going to use this side angle pair, and then I'm going to use my third piece of information. So it doesn't matter what order I'm doing this in. So since I'm looking for a side, I'm going to use the sides in the numerator form, which is called the standard form. Okay, so setting up my equations. I'm going to set up the fraction I know. So this is side B is what I'm solving for. You know what? I'm going to set it up where you use the one that you know first. So I'm going to say side A over the sine of angle A equals side B over sine of angle B. Okay, so substituting in my side A is 12.75. The sine of angle A is sine of 68.41 degrees equals side B over the sine of 54.23 degrees. Okay, so these are equivalent fractions, and I am solving for B. So I know that I'm going to cross multiply these two, and I'm going to divide by this. So I know that side B equals 12.75 times the sine of 54.23 degrees divided by the sine of 68.41 degrees. I find that these work really good if you're using that alpha y equals in the calculator, so you're using the fraction mode. So solving for B, I get B is approximately 11.13 feet. Okay, so I get B is 11.13 feet. Are we in feet? I wrote inches up here. This should be feet. Okay, so the next step I know is I have two of my three angles. So I know when I add up all three angles, these total 180. So to find the next step, I am going to calculate angle C. So I know angle C is 180 minus 68.41 minus 54.23. So I get angle C is 57.36 degrees. Okay, and again, I'm kind of using lines to segregate my work. Most people do that. It just shows everything really clearly what you're doing. Okay, so my last part I need to solve for is side C. So I'm going to go back to using original information. So I am going to use the sine of A. I'm going to use A and C this time as my two fractions. So I'm using my fraction in the same order. So this is going to be sine, this is going to be A over sine of A equals C over sine of angle C. So substituting in, I have A is 12.75 divided by the sine of 68.41 degrees equals C over the sine of 57.36 degrees. So again, I'm going to cross multiply these two and divide by my third. So I get C equals 12.75 times the sine of 57.36 degrees divided by the sine of 68.41 degrees. And I get C is approximately 11.55 feet. We got 11.55 feet. Okay, so here C is 11.55, 57.36 degrees, and 11.13 feet. Okay. So this is how the order I approach this every time I'm given two sides and one angle. And the angle is it included or not included? So two sides and a non-included. Okay. All right, let's see. Let's do the next type. Okay, so when do I apply the ambiguous case? Is when I have two sides and the non-included angle. And if you spell this backwards, it's an obscene word. And in math, we're polite, so we write it as SSA. So we call this the ambiguous case because I can have more than one triangle. Right now, this particular lesson, we're just going to solve for the first triangle, not the second triangle. So the process is the same. Put this three pieces of information on my triangle. So I am going to set this up, and I like to say this is A is the bottom left, B is the bottom right, angle C is the top. So we are given that A is 36 degrees, side A is 8 inches, and side B is 5 inches. Okay, so I'm going to put this in my graphic organizer, and B is 5 inches. So I'm always using the side angle pair first. And then I'm going to use my two fractions with A and B, and I'm going to solve for angle C first. So since I'm looking for an angle, I'm going to use the reciprocal form. So that's in the denominator. So the sine of angle A divided by side A, and the sine of angle B divided by side B. So now I'm going to substitute in. So I'm going to say the sine of angle A is 36 degrees over side A of 8. So the sine of angle B over side B, which is 5. So again, I'm going to cross multiply by those two and divide by this. So I get the sine of angle B equals 5 times the sine of 36 degrees divided by 8. Now I want to solve for angle B, so I have to undo the trig term. So I'm going to take the inverse. So I'm going to take the sine inverse. So angle B is the sine inverse of 5 times the sine of 36 degrees divided by 8. So I have an inverse with a sine as part of it. So putting this in my calculator, I get angle B is approximately 21.55 degrees. Okay. Okay, so I'm going to find the third angle next. I'm going to use the triangle sum theorem, so I know when I add all three angles, they total 180. So the measure of angle C is 180 minus 36 minus 21.55. And I get angle C as 122.45 degrees. So 122.45 degrees. So next I'm going to find side C, and I'm going to use my original fraction with my side angle pair with A. So this time I'm going to use my fractions with A and C. So I'm going to set up sine, and I'm going to use sine of 36, sine of angle A, divided by side A, which is 8, equals the sine of C, which is 122.45 degrees, divided by side C. So I'm going to multiply, cross multiply, and divide by my third. So I get side C equals 8 times the sine of 122.45 degrees divided by the sine of 36 degrees. So again, I would use that fraction, alpha y equals, and I get C is approximately 11.49 inches. And I wrote 49 inches. 11.49 inches. So 11.49 inches, 21.55 degrees, and 122.45 degrees. Okay, I just want to point out I cannot use the Pythagorean theorem finding the sides. And the reason I can't is I do not have a right triangle, and the Pythagorean theorem only applies to right triangles. Okay, let's do a word problem with these, because the purpose of studying anything is word problems, because all of the real world is word problems. Okay, because of prevailing winds, a tree grows so that it was leaning 6 degrees from the vertical. At a point 30 meters in the opposite direction from which the tree is leaning, the angle of elevation to the top of the tree is 22.5 degrees. How tall is the tree? Okay, so I'm going to draw an angle, a triangle first. So this would be if my tree was standing up straight. But my tree is not standing up straight. It says it is at an angle. So I'm going to draw my tree at an angle. And it says it's at a 6-degree angle. So this is 90 plus 6, which is 96 degrees. And then it says I have an angle of elevation of 22.5 degrees. So here's my angle of elevation here. And the angle of elevation is 30 meters from the tree. Okay, so I'm going to just set up my chart here. I have A, B, C, A, B, C, and I'm going to label my points. So I have A, B, and C. So angle A is 22.5 degrees. B is 96 degrees. And side C is 30 meters. Okay, so the first thing I see is I do not have Okay, the first thing I'm noticing is that I do not have a side angle pair. But what I do know is I have 2 of my 3 angles, so I can solve for my third angle, C, and then I will have a side angle pair. So the first thing I'm going to do is solve for angle C. So I know angle C is 180 minus 22.5 minus 96. So angle C is 61.5 degrees. So we are trying to find how tall the tree is. So that is side A. So now I'm going to apply the law of sines. Oops. So the law of sines. So I'm going to say the sine of angle A. So the sine of 61.5 sine of angle C, I'm sorry, because I'm using my angle side pair divided by side C, which is 30. And I'm trying to find side A, so I want angle A. So sine of angle A, which is 22.5 degrees, divided by side A. So I know I'm going to cross multiply these two and divide by my third. So A equals 30 times the sine of 22.5 degrees divided by the sine of 61.5 degrees. So I get A is approximately 13.06 meters for my tree.